UDL, there is this deflection, let's call this as delta B, and at the same time we will have some rotation at this point, and that will be theta B, right? And now, just like we discussed in the last class, first we will apply the first reaction because we have removed two unknowns. At B point, we have one vertical load or one vertical reaction, and the other one is the movement. So we will apply firstly the vertical reaction at this end, and then apply the movement. So the vertical reaction at this point, let's call this as VB. And due to this reaction, again, we will have some deflection and some rotation. Let's call this deflection as delta BB and this rotation as again theta dash BB. Yes.
आपने फिक्स सपोर्ट हटाया है ना, तो अभी आप पिन सपोर्ट क्यों नहीं लगा रहे प्राइमरी स्ट्रक्चर में?
इसमें मेरे पास कितने अननोन्स हैं, कितने एक्स्ट्रा अननोन्स हैं?
4 हैं।
एक्स्ट्रा हमारे पास 2 हैं, 2 तो हम इक्वेशन ऑफ इक्विलिब्रियम से फाइंड कर सकते हैं, राइट? अब जो पहले हम क्वेश्चन करते रहे हैं उसमें एक सिंगल हमारे पास मतलब 1, 2 एंड 3, ठीक है? तो एक्स्ट्रा कितना होता था? 1 होता था, राइट? तो इस एक रिएक्शन को फाइंड करने के लिए मैं इसकी एक कंडीशन को जो है या एक रिएक्शन को रिडंडेंट कंसीडर करूंगा। तो मैंने इस केस में मूवमेंट को अगर रिडंडेंट किया तो तब मैंने इधर हिंज सपोर्ट या फॉर दैट केस आप रोलर भी लगा सकते हो, क्योंकि इस केस में मैटर नहीं करता, आपके पास हॉरिजॉन्टल फोर्स तो है नहीं। तो इस केस में मैंने लगाया क्योंकि मैंने एक रिएक्शन उधर ही रखा है और मेरे पास एक एक्स्ट्रा अननोन रिएक्शन है, दैट इज मूवमेंट, जिसको मैंने इस डिफ्लेक्शन या कंपैटिबिलिटी इक्वेशन से फाइंड करना है। लेकिन इस केस में मेरे पास 2 एक्स्ट्रा अननोन्स हैं, तो फिर मैंने पूरी फिक्स सपोर्ट को हटा दिया, राइट?
अगर हम लोग हॉरिजॉन्टल कंसीडर करते फिर हम पिन लगाते
इस केस में।
हाँ, अगर
हम हॉरिजॉन्टल कंसीडर करते तो ये जो मेरा प्राइमरी स्ट्रक्चर है ये डिटर्मिनेंट होता है या ना, या इनडिटर्मिनेंट होता?
ये इनडिटर्मिनेट होता।
तो ये भी इनडिटर्मिनेट हो जाता। तो प्राइमरी स्ट्रक्चर तो आपका डिटर्मिनेट होना चाहिए ना, जिसके अकॉर्डिंग फिर आपने इक्वेशन लिखनी है। अगर यही मेरा इनडिटर्मिनेट है तो इसका पर्पस क्या होगा पूरी प्रैक्टिस का?
ना मर करे देगा ना मखस रूना जो बदल अल्तना क्या सही था।
कैन यू प्लीज टर्न ऑफ योर माइक आलियान? और आप बैठे किधर हो? कैफे में बैठे? तो अगर यही मेरा प्राइमरी स्ट्रक्चर ही इनडिटर्मिनेट हो जाता तो फिर मेरा पर्पस क्या था इस चीज को करने का? हमने प्राइमरी स्ट्रक्चर को अपने डिटर्मिनेट बनाने और फिर उसके अकॉर्डिंग हमने अपनी इक्वेशन लिखनी है, राइट?
सर तो इसमें जो हमने एक सपोर्ट हटा दिया तो वो अब हमारे पास रिडंडेंट स्ट्रक्चर है।
एक सपोर्ट हटा दिए तो
अब हमारे पास ये रिडंडेंट तो नहीं है ना, मतलब हम उससे पहले वो बना रहे होते हैं ना एज इन प्राइमरी स्ट्रक्चर के लिए।
ये हमारे पास प्राइमरी स्ट्रक्चर है और ये डिटर्मिनेट है, ठीक है? अभी हमने ये देखें एक रिएक्शन लगाया, जस्ट लाइक इन द लास्ट क्लास वी डिस्कस। अभी हमने इस पे एक रिएक्शन लगाया, फिर हम इसके पास दैट इज मतलब ये हमारे पास वी बी अननोन है जो कि हमने कंपैटिबिलिटी से फाइंड करना है। और फिर इसी तरह हमारे पास ये जो थर्ड बीम है इस केस में हम मूवमेंट लगा देंगे क्योंकि हमने मूवमेंट को भी रिमूव किया, मूवमेंट और वर्टिकल रिएक्शन दोनों को रिडंडेंट कंसीडर किया, राइट? तो इस मूवमेंट की वजह से फिर इसमें डिफ्लेक्शन प्रोड्यूस होगी, दैट वी विल कॉल एज डेल्टा डैश बीबी, और इसकी वजह से जो रोटेशन प्रोड्यूस होगी दैट विल बी थीटा बीबी। सो अब मेरे पास ये वीबी भी अननोन है और ये एम बी भी अननोन है, जो कि मैंने कंपैटिबिलिटी कंडीशन से फाइंड करना है। तो मैंने इन दोनों को रिमूव किया था, और फिर जब मैंने प्रिंसिपल ऑफ सुपरपोजिशन अप्लाई किया तो मैंने इन दोनों को सेपरेटली फाइंड किया, और अब मैं इनके साइमल्टेनियस इफेक्ट को कंसीडर करके हम कंपैटिबिलिटी इक्वेशन लिखेंगे और फिर उसको सॉल्व करके हम ये फाइंड करेंगे। इज इट क्लियर?
Yes, sir.
So now start writing the compatibility equation for this structure for these 4 beams. So what will be equation 1? Anyone? Class.
Delta V plus delta BB plus delta dash BB.
Yes, it's that simple. So it will be delta V plus, because in the initial one we have this deflection, in the second one we have this deflection due to this vertical load, and in the third one we have delta dash BB. So can I replace delta B with FBB VB plus this delta dash BB is due to this particular movement. So I will replace this with F dash BB into movement, right? So is there any confusion about this one? In fact, with movement we usually apply the rotational flexibility. And for rotation, we have in the initial structure, the rotation was 0, which was our actual structure. And in the primary structure, we have this theta B. In this structure, we have this theta dash BB. And in this third structure, we have again theta BB. And on the same grounds, I can replace it with 0 is equal to theta B plus what is this theta dash BB. I can again replace it with alpha dash BB due to this force of, actually I wrote it wrong, it should be F dash, because deflection is always due to the flexible rotation, or due to linear flexibility, and the rotation is due to angular flexibility. And this one is alpha BB into M. Now I need to figure out these deflections, these flexibilities, and once I have these values, I can simply substitute into these two equations and I will get directly these unknown reactions and these movements. So again, in the book, the direct formulations are given for the calculation of these factors. For example, I will just write it over here. If we have a fixed beam on which this load of W kilonewton is acting, the deflection at the extreme end, or the maximum deflection, would be WL4 over ATI, and rotation at free end would be WL cube over 6 EI, right? So from our case, we need the load W is acting over here, and it is producing the deflection delta B and the rotation as theta B. So for our case, this maximum deflection would be equal to delta B, and this maximum rotation would be equal to theta B. So now we have these two unknowns, that is delta B and theta B. this theta b, and we need these flexibilities and rotation. And from the same concept, if you see the book, there will be this formulation that when a load of P is acting, it will produce some kind of rotation and some kind of deflection in this particular beam. So the rotation, this deflection would be delta is equal to PL cube over 3 EI. Class, just give me a moment. Okay, sorry about that. So when a unit load is acting on a particular beam with a fixed end, there will be some deflection that will be produced in this one, and also at the same time, we have this rotation that let's call it as theta. So this deflection is equal to PL cube over 3 EI, and this theta is equal to L square over 2 EI. So can anyone tell me that how can we correlate this deflection and rotation with flexibilities? Which flexibility will be this one? From this, we have 4 flexibilities, this FBB, this F dash BB, this alpha dash and alpha BB. So which one will be this deflection? This one. Anyone? Or how can we correlate this with this FBB?
सर FBB ये आप हम यूनिट लोड अप्लाई कर रहे हैं.
Actually, the formulation is for the load of P, but this you should know that flexibility is equal to deflection when the unit load is acting on the beam. So we will modify this beam slightly and apply a unit load at this point. And due to this unit load, there will be some deflection, and this deflection will be again FPB, and there will be some rotation as well, just like this beam. And this rotation would be alpha dash BB into VB. So this rotation that will be produced as a result of this unit load will be alpha dash BB. So this basic, can you please turn off your mic? So this deflection, if I replace this P by 1, and over here there is also I think P factor. So if I replace this P factor with 1, I will get, or this deflection would be equal to flexibility at point B due to the unit load or the vertical unit load of 1. So this flexibility would be L cube over 3 EI, and this rotation would be equal to alpha dash BB L square over 2 EI. So now we have,
there is a lot of lag.
okay. So basically what is flexibility? Flexibility is equal to rotation when the load, when the unit load is acting on the beam. So From the direct formulation, we have the formulation when a unit load of P is acting on the free end of a fixed ended beam, and it will produce some kind of deflection and rotation. So we have direct formulation. The formula for the deflection is PL cube over 3 EI, and for the rotation, the formula is PL square over 2 EI. But we need flexibility, not the rotations or deflection. So what will we do? We will apply a unit load at this free end. So one way is that you solve it by any method of calculation of deflection like conjugate beam or moment area method or virtual work, or you can use these formulas directly. So if you have to use it directly, you will simply apply the unit load at this point, and due to this unit load, the deflection that will be produced will be equal to linear flexibility, that is FBB, just like this beam. For example, in this beam we have two deflections, linear and angular, two displacement. So the linear deflection that will be produced will be equal to FBB, and the rotational deflection that will be, or rotation that will be produced would be equal to rotational flexibility, that is alpha dash BB. And in the same formula, we will replace this P with 1 and this P with 1, and that will be directly equal to our flexibility factor. So from these two equations, now we have this deflection as well and this flexibility as well. And in this one, we have this rotation. Yes.
सर ये जो अल्फा डैश बीबी है ये अल्फा बीबी नहीं होगा
No, it
जब
will
हम
be
इसका
alpha.
कोरिलेट
No, actually alpha dash, that's why I have written alpha dash sign with it, because basically rotation is being produced due to when the rotation, when the movement is been acting, then basically usually the rotation is being produced. But in this case, the unit load is acting, which is producing the movement directly, which is producing this rotation theta dash BB. And in this case, the movement is, or you can name it alpha BB or alpha dash BB, but just to differentiate that this alpha dash BB is the rotation which is being produced in this beam due to this vertical unit load, and this alpha BB will be the flexibility which will be produced in this beam due to this movement that is acting on this beam. So you can name it as in any way that you like, but you should know what is the difference. Alpha dash BB is the rotational flexibility when vertical reaction is being acting, and alpha BB is the rotational flexibility when the unit movement is being applied to the beam. Is it clear?
yes sir
So we have this two flexibilities, and now in the third case, or the remaining two unknowns are this alpha BB and this F dash BB, right? So again, for this one, we have one formulation, and these formulations are given at the start of your Hibbeler book, so you can use those. So for this beam, we have V max is equal to M naught L over 2 EI and theta will be equal to L over EI. So again, if I want to correlate this with the flexibilities, let's just apply it in this direction. So with the flexibilities, it will produce linear deflection that will be equal to linear flexibility, and it will also produce some angular displacement, and that will be equal to angular, let's call this as F dash BB and this as alpha BB. So FBB or F dash BB will be equal to L over 2 EI, actually it is L square, and alpha BB will be equal to again length over EI. So now we have all four unknowns, and we just need to solve this equation simultaneously to get the values of these unknown reaction VB and MB. So let's just substitute these values back into this equation. So let's name this. So when I substitute the values in equation 1, I have deflection that is equal to WL4 over 8 EI, that is this one, that is this one, and next thing is in equation 1 I have to substitute FBB, and this FBB will be equal to L cube over 3 EI, and this F dash BB would be equal to L square over 2 EI, which is written over here. So minus, actually it is with a positive sign. Yeah, L cube over 3 EI into VB plus this third one, L square over 2 EI into MB equals to 0. Let's call this as our equation 3. So if I simplify this one, this EI will cancel out because they will go on to this side and multiply with 0. And if I multiply this one by 24, I will get 3WL4 plus 8L cube into VB plus 24 or 12L square into MB is equal to 0. Let's call this as equation 4. In the same way, let's substitute the values in. And again, I'm suggesting you to make your own notes because this solution is not available in any book and you may get confused later on. So if I substitute the values back in equation 2, which is this equation, so theta B is this one, that is WL cube over 6 EI. So it will be WL cube over 6 EI plus alpha dash BB is this one, that is L square over 2 EI into VB, and alpha BB will be L over EI. L over EI into MB equals to 0. So again, I will multiply this by 6. This EI will cancel out because it will go on to that side, and we will have WL cube plus 3L square into VB plus 6L into MB, that is equal to 0. Let's call this as equation 5. Now we have these two equations, this equation 4 and this equation 5, and there are two unknowns, this VB and MB, and so there are two unknowns and two equations, so we can solve it. And so let's just try it. So again, if I simplify this up, that will be 3VB L square equals to, this will go on to this side, that will be minus WL cube minus 6L into MB. So the equation for VB will be minus WL cube, this factor will come onto this side, 3L square minus 6L MB over 3L square. So VB will be minus WL, this will cancel out, over 3, and this will be minus 2MB over length. This will cancel out, this will be 2, so we'll have 2MB over L. So now we have the value of VB, and if I substitute this back into this equation, I will get something for, I will get the values of MB. So that will be 3WL4 plus 8LQ, and VB is minus WL over 3 minus 2MB over L plus 12L square into MB equals to 0. So that will be 3WL4 minus 8WL4 over 3 minus 16 MB L square plus 12 MB L square equals to 0. So this one will be 9WL4 if I take the LCM, and this one will be 8, this one will be 3, and this whole term will be 4MB into L square equals to 0. So this whole term will be WL4 over 3 minus 4MB. Actually, it is just the simplification, so you can understand it. So this will be WL4 over 3 is equal to 4MB L square, and the final answer for MB will be WL square over 12. So this is the moment or the unknown moment at the fixed end. Now if I substitute this moment back into this equation, I will get the value for the shear force, and I leave it up to you to calculate this shear force, and the final answer for the shear force will be minus WL by 2. So actually the minus sign would mean that the direction that we initially assumed was not correct, and we have to change the direction. For example, in this beam over here, we have assumed the direction of this vertical direction as downward. So that means that this direction is not correct, and the actual direction is upward for this VB force. So that's what I told you in the last lecture, that just go on with the calculation, and at the end if you get the negative sign, you will get the idea that what is the final direction. So if I again draw this beam, now I have this reaction as WL by 2, this movement as WL square by 12. There is a load of W that is acting on this beam. So can you give me these two reactions now? Or can you calculate these two reactions? Usman, can you hear me? Zia,
जी सर
उस्मान, क्या होंगे ये रिएक्शंस?
WL/2 होगा ये पॉइंट
कौन सा ये?
सर वर्टिकल रिएक्शन
And what is this reaction?
जी सर
Can you please? What will be this movement?
सर ये डबल
So what is this moment? Anyone?
WL squared divided by 12.
So this is also WL square over 12. So also we were supposed to plot the bending moment diagram. So for this beam, if I plot this diagram, it would be something over here. It is negative, then it will continue to increase. What will be this component at the center? This will be WL square by 12. This will be WL square by 12. What will be this component? Anyone? Is it that difficult?
So it's simplify नहीं किया but minus WL squared by 12 plus WL squared by 2.
So final will be WL square by 24.
Yes. Yes.
So this is how. So now you have solved an indeterminate beam with degree of indeterminacy equals to 2 by using this method. So is there any question or confusion about this one?
Sir, can you show the original structure?
This one.
यस सर. सर अगर यहाँ पे बी पॉइंट पे फिक्स सपोर्ट की जगह अगर होती रोलर सपोर्ट तो हम उसका रिडंडेंट फोर्स कंसीडर करते वर्टिकल फोर्स और वो सिर्फ
Yes.
एक ही प्राइमरी स्ट्रक्चर होता और रिडंडेंट मोमेंट हम सिर्फ तभी लेते हैं जब साथ यहाँ पे फिक्स्ड एंड हो.
Yes. हम इसमें भी redundant movement ले सकते थे ना. मतलब हम
नहीं, अगर
कंसीडर
यहाँ
कर
पे सपोर्ट होता तो फिर तो हमें रिडंडेंट मोमेंट की जरूरत नहीं थी ना.
राइट हैंड पे अगर आपने लेना था तो फिर ये वर्टिकल को आप रिमूव कर देते तो ये डिटर्मिनेंट बन जाती. दैट विल बी दिस प्राइमरी स्ट्रक्चर एंड देन आपके पास सिर्फ ये दो स्ट्रक्चर्स होने थे, तीन नहीं होने थे.
सही. यस.
एनी अदर?
सर ये जो प्राइमरी स्ट्रक्चर जो है प्राइमरी स्ट्रक्चर के बाद जो दूसरा है उसमें हम आपने थीटा डैश बी भी लिया ना. हम मतलब ये मैटर करते हैं नोटेशन. अगर हम लोग इसको थीटा बी भी ले लें और नेक्स्ट वाले को थीटा बी भी प्राइम ले लें.
नोटेशन मैटर नहीं करते. इट इज अप टू यू टू सेलेक्ट दिस नोटेशन. बस आपने ये चीज़ देखनी है कि जब आप कैलकुलेशन कर रहे हो या इक्वेशंस लिख रहे हो इसकी रोटेशंस की, तब ये चीज़ ख्याल रखनी है कि जो थीटा डैश बी भी है वो वर्टिकल लोड जब लग रहा था तो उसकी वजह से जो रोटेशन थी. तो यहाँ पे अब हमने जब ये फ्लेक्सिबिलिटी कैलकुलेट की थी, वेरी गुड, मतलब थीटा डैश बी बी की वजह से हमने इसको अल्फा डैश बी बी बनाया था दिस वन. और जब हमने ये फ्लेक्सिबिलिटी कैलकुलेट की थी तो यहाँ पे यूनिट लोड वाला केस था, उसके अंदर जो रोटेशन थी दैट वाज इक्वल टू अल्फा डैश बी बी. ठीक है, तो ये चीज़ आप इसमें कंफ्यूजन नहीं करनी और नोटेशन इट डजंट मैटर, आप कोई भी ले सकते. इसी तरह जब मूवमेंट था हमारे पास तब हमने इसको अल्फा बी बी कहा था जब मूवमेंट लग रहा है. तो इधर जब हमने कैलकुलेशन की थी दिस वन, तो ये जब मूवमेंट लगाया था हमने यूनिट, तो उस वजह से जो डिफ्लेक्शन रोटेशन थी उसको हमने अल्फा बी बी कहा था. राइट.
ठीक है सर। और अगर हम लोग ए पॉइंट पे फॉर एग्जांपल हम लोग रिडंडेंट लोड और रिडंडेंट मोमेंट लेते हैं, तो तब भी हम वहाँ पे यूनिट लोड लगाएंगे ना, और तब भी मतलब ये इक्वल होंगे, मतलब जो फ्लेक्सिबिलिटी और एंगुलर फ्लेक्सिबिलिटी जो होगी वो भी ये जो हमारे पास जो इक्वेशंस थी WL 4/8 आई और वो जो V मैक्स और थीटा मैक्स की इक्वेशंस
yes
थी, फिर भी वो
yes
बराबर होती। लेकिन सर
yes they are.
न्यूमेरिकली तो फिर L 0 होता ना जब हम इसको सब्स्टिट्यूट
तो
करते।
आपकी सेम ही कंडीशन है ना, मतलब फॉर एग्जांपल अगर ये हो एक रोलर बीम और एक बीम ये हो, इन दोनों में कोई डिफरेंस है? उसकी जो लेंथ थी वो आप इस एंड से लेनी पड़नी थी, क्योंकि आपकी लेंथ फिक्स एंड से के रेफरेंस से आ रही है,
नहीं तो
राइट?
इसमें हम लोग सेम ही होगा लेंथ, फिर हम लोग दूसरी साइड से कंसिडर करेंगे, मतलब राइट से।
मतलब राइट साइड से। आप ये बताएं, इन दोनों फिजिकली देखें ना, अभी लेंथ को छोड़ दें, इन दोनों बीम्स में कोई डिफरेंस है?
नहीं।
नहीं है ना। तो इसीलिए जब ये जो हमारे फाइनल आंसर्स आए हैं, ये फाइनल आंसर आए हैं, दोनों एंड से सेम ही आए हैं। अगर आप उधर से भी चलते तब भी आपके पास यही आंसर आने थे। बस एक डिफरेंस यही है, मैथमेटिकली देखें तो अगर आपके पास इस तरह पहले हमने लिया है तो वो रेफरेंस पॉइंट आपका ये फिक्स्ड एंड था। अगर आप यूं देते तो फिर आपका रेफरेंस पॉइंट ये हो जाता। ठीक है, और बुक में भी इसी रेफरेंस से दी होगी। अगर इस तरह का कोई केस होगा तो वो आपकी जजमेंट पे है कि आपने कहाँ से लेंथ लेनी है। तो ऑब्वियसली आप बुक में ये देखेंगे कि आपकी रेफरेंस क्या है। रेफरेंस आपका फिक्स सपोर्ट है तो आप इस केस में भी रेफरेंस फिक्स सपोर्ट ही रखेंगे, राइट?
ठीक है सर, बट आपने जो कल उस दिन एग्जाम्पल करने का कहा था, तो उसमें ए पे हमने रिडंडेंट लगाना था ना, तो
यस।
उस केस में फिर हम लोग फिर रेफरेंस ए पॉइंट को ना लेते।
आप पहले उस केस में ये देखते हैं आप किस तरह उसको कैलकुलेट कर रहे थे। कोई आपने बीम लिया था या आपने मोमेंट एरिया मेथड से किया था, कैसे किया था?
सर मैंने मोमेंट एरिया के उससे करने की कोशिश की थी पर हुआ नहीं। लेकिन मतलब मुझे ये था कि रेफरेंस कौन सा लेना है, मैं इसी में कंफ्यूज हो रही थी कि
वो
रेफरेंस
डिपेंड करता है, वो डिपेंड करता है उस पर कि आपके पास, मतलब फॉर एग्जांपल आप वो क्वेश्चन ये क्वेश्चन था समथिंग लाइक दिस, राइट? और ये यहाँ पे लोड लग रहा था। अब आपने क्या फाइंड करना था, इसमें रिटर्नेड रिएक्शन ही फाइंड करने थे, तो इसके नीचे वाली डिफ्लेक्शन। तो आपने देखना था कि आपके पास फिक्स बी सिंपली सपोर्टेड बीम की कोई इक्वेशंस अवेलेबल हैं बुक के अंदर डायरेक्टली, अगर आप डायरेक्टली करना चाह रहे हैं। तो इस केस में फिर आपने देख लेना था कि उसमें उसमें मेंशन किया होता है कि रेफरेंस कहाँ से हो रहा है। तो अगर उसी के अकॉर्डिंग आपकी बीम है एग्जैक्टली तो आप वही रेफरेंस ले लोगे, अगर उससे डिफरेंट है तो आप रेफरेंस चेंज कर दोगे।
ठीक है, ठीक है सर, थैंक यू।
So, so there is an assignment problem. Can you see the slides? So in this one, you have this assignment problem over here in which there is a fixed end on A point, there is a hinge support at B and again a hinge support at point C. So we have 1, 2, 3, 4. Again, there are two extra unknown reaction, or the degree of indeterminacy for this beam is 2, and you have to analyze it and find the reactions. So it will be quite simple because there are actual mathematical values, not the variables. So it would be quite easy to solve this question. And let's solve another question in this class, which is slightly different, but again the method is same. We have this beam on which there are two roller support and a hinge support, and there is a UDL of 3 kip per foot and a point load of 12 kips that is acting on this one. So we have this beam on which a UDL of 3 kip per foot is acting. There is a point load of 12 kips. This is 6 feet, 6 feet, and 12 feet. A, B, and C. And we are supposed to analyze it and figure out the reactions. So can anyone tell me what will be the compatibility equation? Or let's just plot the structure. This is our actual structure. In the primary structure, let's consider this central support as redundant, and we would remove this one and plot our primary structure. So this primary structure is now determinate, and there is a UDL of 3 kip per foot and this point load of 12 kips that is acting. This deflection at the center, let's call this as delta B. So this is our primary structure, and actually in this one we just have to remove, it is the simple case in which we have to remove only one support because there is one extra unknown reaction, or degree of indeterminacy is 1, so we have to remove only one particular support and we can get to the result, right? So this is our primary structure, and in the structure on which we would apply the redundant reaction or redundant movement would be this one. Let's apply the moment redundant reaction in this upward direction. So due to this, it will also deflect, and there will be some deflection, and let's call this as delta dash BB. Actually, BB means that it is the deflection at point B due to the load acting at point B. So if I write the compatibility equation, that would be zero. There is no deflection in the actual structure, and in the primary structure we have delta B, and in this third structure we have in the opposite direction minus delta dash BB. So 0 is equal to delta B minus, if I replace this delta dash BB by, again the flexibility, it would be FBB into BY. So this is our equation. So is there any confusion about this one? So I hope that everyone got this, but there is a problem. If, let me show you the book.
एक्सक्यूज मी सर,
Yes.
सर इस पे अगर हम ए बी सी पे मोमेंट इक्वेशन लिखे तो 3 इक्वेशंस आ जाएंगी और 3 अननोन्स.
अच्छा, who is asking this question?
असद सर.
अच्छा असद, आपने ना ये करना है. इट्स अ गुड क्वेश्चन कि आप तीनों पॉइंट पे इक्वेशन लिखो, 3 इक्वेशन आएंगे, 3 अननोन्स आएंगे, लेकिन ना आपने ये ट्राई करना है और फिर आपने बताना है कि क्या इशू आया था उसको सॉल्व करने में. ठीक है, you should try this, or anyone else who is interested can try this, that write the equation of movement at A, B and C and try solving it and just tell me कि क्या issues आए थे, फिर हम इसको डिस्कस करेंगे. Okay, actually this is our compatibility equation. Now the problem is, these are the equations or these are the direct formulations that are given, but in this one they have given us the formulation only for the single load. For example, this beam only point load is acting, and in this fourth beam, in this one, there is only UDL is acting, that is similar to our case. But there is no case in which the combination of these two loads, for example, in our case, there is a combination of load, this 12 kips and 3 kip fit. So there are two ways, it's up to you. One, that you use any method of calculation of deflection and you figure out the deflection. But if you want to use the direct formulation, you don't have any formulation for this kind of a combination of load. So you will further divide to make things easier for you. You can further divide this one into two beams. For example, let's just erase it. Now, since I don't have direct formula, I would say that in my first beam, there is a load of 3 kip per foot that is acting on this beam, and it will produce a deflection delta dash B. In this, you can do it by the previous method that I told you, but for that, you have to apply some method to calculate the deflection. Or you can do this one. For example, in the first case, you would say that only the UDL is acting, which will produce the deflection delta dash B. And in the second case, we would say that only the point load is acting of 12 kip and it will produce the deflection. Let's call this as delta double dash B. And in the third case, that reaction is acting, the redundant reaction is acting, which will produce the deflection delta, let's call this as triple dash B. So if I write the compatibility equation for this case, it would be delta B plus delta dash B, delta double dash B plus delta DB or triple dash B. Okay, so now I have delta dash B, which is the deflection due to this UDL, this delta double dash B, which is the deflection due to this point load of 12 kip, and this third deflection, which is due to this reaction. So this one I can replace with flexibility. There should be a negative sign. So that will be delta dash B plus delta double dash B minus, this would be FBB into BY. So this can be also a compatibility equation, and now we can use the direct formulation to figure out this deflection. For example, for the first case in which the point load is acting or UDL is acting, the formula for the deflection at center is, this is 24 feet, this is 24 feet. It is delta is equal to minus, just ignore the sign of this one, Wx over 384 EI into 16x cube minus 24 Lx square plus 9L cube. So if I substitute the values, this x is the distance or the point at which you want to find the deflection. For example, in this case, we need the deflection at this 24 feet. Sorry, this is 12 feet actually. This is also 12 feet. So for example, in this case, we would like to find the deflection at the center, that is at 12 feet. So x in our case will be 12. So if I substitute the values in this one, this load is 3 kip. So this would be 3. This x is 12. This will be same, 16 into 12 cube minus 24. Length is 24. X is again 12 square plus 9 into 24 cube. So what will be the value of deflection due to this UDL? Can anyone give me this answer? Class, what will be this deflection? So this deflection, that is delta B dash, is equal to 6480 over EI, and the units are kept fit Q, right? And for the case when a unit load is acting, this formulation is not given in this book, so just note it down. When a unit load of P is acting and this distance is A, this distance is B, and there is an X distance, so the deflection would be PAX over 6L EI into L square minus A square minus X square. So this A is the distance of this point load from the left support, X is the distance to the point at which we would like to calculate the deflection, and L is the total length. So for our case, we have this beam on which this 12 kip is acting at 6 feet. This is 6 feet, and again this is 12 feet. And we would like to calculate the deflection at 12 feet. So X is equal to 12, A is equal to 6 feet. So if I substitute the values, P is equal to 12, A is equal to 6, X is equal to 12, 6, total length is 24. This EI will remain as it is. Length again is 24 square, A is again 6 square, X is 12 square. So what is the deflection? Or this one is delta V double dash. $23.76 over EI kept fit Q. So now if I see this equation, where is our, this one? This is our compatibility equation. We have this delta dash B, this delta double dash B. We only need FBB and we can figure out BY. So for FBB, we know that if there is a beam on which a load is acting at the center, the deflection is PLQ over 48 EI, right? So we want to find the flexibility. So flexibility would be, again, we would replace this by 1 and the deflection would be PL cube. So this will be 1. So flexibility will be L cube, that is 24 for our case, over 48 into EI. So what will be flexibility? This P is 1.
Set 288 over E.
So this will be 288 over EI fit cube. So now we have all three unknowns and just we need to substitute into this equation. And when we do it, we will get 6480 over EI plus 2376 over EI minus 288 over EI BY, that is equal to 0. And what will be BY now?
30.75.
Yes. So By would be 30.75 kips. So we have one unknown reaction in this beam, and now we can apply the equation of equilibrium to find out the other reactions. So in this beam, this reaction is 30.75. This is a hinge support. We have the rollers UDL. This is 12 kips, 6 feet, 6 feet, 12 feet. So what will be this reaction? RA. And what is RC?
तो यार नया क्वेश्चन करा रहे हैं
It's the same question. हमने बाकी चीजें भी तो फाइंड करनी है. अभी तो हमने सिर्फ ये एक रिएक्शन फाइंड किया.
वहाँ से सॉरी
So what is RA? Can you give me this answer? So let's write the equation. That would be RA multiplied by 24 equals to 12. Just write it again. Minus 12 into 18 plus 30.75 into 12 minus 3 into 12 into 6 equals to 0. So when you solve this, you will get RA equals to 2.625 kips. So is there any confusion about this one? And what is RC now?
14.625.
How much?
14.625.
So this is 14.625 kips. So now we have all the reactions and we can plot the shear force diagram and bending moment diagram. This is 2.625, this is 30.75, this is 14.625, and over here we have 12, this one is 3. So if I plot the shear force diagram, it would be 2.625, then it will go there, come down. What will be this component? And this component. So this is 2.625. What will be this component, anyone? 9.375. And this one is 21.4 something. So this is the shear force diagram, and again this will be the bending moment diagram, and I expect you to plot this quickly. And from this diagram, if these diagrams are closing at the end point, this means that your calculation are correct. So this is the bending moment diagram. So this is how you have to solve. This is it from the application of force method to the beams. In the next lecture, we will be starting this force method for the frames and then trusses. So is there any question about this particular question? So if there is no question, then there are two more assignment problems in these slides. One is this one. This one is quite similar to what we have already done. There are 2 point loads and the distances are given. You are supposed to analyze and plot the diagrams. And there is another question, that is this one. There is a small difference in this problem. Again, you are supposed to analyze this one, but there is a condition that the support at point B, it's mentioned that the support at point B settles downward by 0.25 feet. And then they have also provided us with the values of I and E. So you have to consider this condition. So can anyone tell me that how this small condition can affect our compatibility equation?
जीरो का इक्वेट नहीं करेंगे सर, उसे डिफ्लेक्शन के इक्वेट कर देंगे.
Yes. In this, for example, they have provided us that the support at B settles downward. So usually we would take this B support as our redundant reaction. So in this case, यहाँ पे हम लोग इसको जीरो के इक्वेट कर देते थे जो भी कंपैटिबिलिटी इक्वेशन थी, बट इसमें हमें बताया हुआ है कि ये सपोर्ट सेटल कर रही है 0.25 पे. सो दिस शुड बी इक्वेटेड बिकॉज ये सब भी डिफ्लेक्शन ही है, डेल्टा डैश बी डेल्टा डबल डैश. सो दिस वुड बी इक्वल टू 0.25 एंड देन इसके अकॉर्डिंगली हमने सारी कैलकुलेशन करनी. सो दिस इज द ओनली डिफरेंस इन दिस वन, एंड अगेन यू हैव टू सॉल्व दिस एंड you will get the reactions and everything. So if there is any question, you can ask me. Otherwise, this is it from today's lecture.